Hello, hello, hello to all our grade 11 mindsetters. Hope you guys are ready for today's mathematics show with myself and a very cool teacher in studio with us, Dina. Now remember, it is our last live Learn Extra show. So guys, we will be actually doing the last show for today with you guys. But don't despair, because from next week on, we're going to be continuing with revision from all the other shows that have been pre-recorded. So let me introduce our teacher for today's show. How are you, Dina?
Hello, Queen. Hello, grade 11s. Lovely to be with you for one last time. I know next time I see you, probably be grade 12s. So let's enjoy today's lesson.
All right. Thank you so much, Tina. Remember, guys, the show is all about you. So please connect with us on Facebook, on Twitter, and that is at www.facebook.com/learnextra. Or you can also connect with us on our Twitter page, and that is at LearnExtra with an X. Or you can even go onto our website, and that is at learn.mindset.co.za to get yourself all the notes and any sorts of material that you guys need. We have so many resources for you guys, so you have absolutely no excuse not to ace those exams. And remember, guys, that our hashtag Get Connected competition still continues, and it is actually in the final week of running. Remember that all you have to do is vote for your favorite teacher by simply going onto our Curio page or going onto our Facebook page and liking the teacher's picture. And remember, if you want your teacher to win, you have to share the picture. You have to tell all your friends, all your family to keep liking the picture, because the picture with the most likes is gonna be our winner. And what is in it for you? You get to win yourself a Sony Xperia L cell phone. Now, who would not want a cell phone, guys? Like, that is a very, very cool gadget for yourself. So just keep voting, and you could be in the running to getting yourself that very cool cell phone alongside airtime from Vodacom. Now, with all that being said, let us actually continue with today's lesson. After all, that's why we're here. Dina, what do we have for the grade 11s today?
The grade 11s, well, we'll be carrying on from last week. Last week we were doing some statistics, and we looked at the measures of central tendency and the measures of dispersion. And so we're going to carry on with some examples around that. I think the more examples we see, the more variety of questions we see, the better we become at it. So that's what we'll be doing.
Great.
Can I go?
Yes, continue.
Good. Right, grade 11. So we spoke about last week the mean and the median, and we spoke about the standard deviation and the IQR. And today we're going to kickstart with some more examples. This section is quite language based. You'll find that you need to work through a text to be able to extract the information and understand how the information is being presented. So in-depth knowledge of the language is quite important in order to be able to do statistics. So let's have a look at the challenge question for today. We have two mathematics classes, A and B, and they are in competition to see which class performed best in the June examination. The marks of the learners in Class A are given below, and the box and whisker diagram below illustrates the results of Class B. Both classes have 25 learners, and the marks are given as a percentage. So there are two ways of actually describing Class A and Class B, box and whisker, and just in a tabulated form. The challenge question is to be able to write the 5-number summary for Class A, to draw the box and whisker plot for Class A, and once you've done that, to determine which class performed better in the June examination, and you need to give reasons for your answer. Okay, so just ignore this little table over here. It doesn't really affect A, B, and C. So we really want you to be able to tell us which class actually performed better in the June examination. Okay, so we'll leave those that are going to be entertained with that question. Let's go on to our summary. Again, very important to understand the three different vocab words around the measures of central tendency, meaning that that's how we can centralize the data and make sense of the data. So we have the mean, which we often call the average. We have the median, which is the middle value. And we have the mode, which is the value that occurs the most times. And then if we look at the measures of dispersion, we really want to know how clustered is that data around the mean or median, so we can make some interpretations, or how widely dispersed is that data around the mean. So the standard deviation describes for us the dispersion around the mean, and the interquartile range describes for us the dispersion around the median. Is it clustered around the median, or is it widely scattered around the median? Okay, so to start us off, we're going to look at the graph below. It shows the monthly maximum temperature in a certain city. So again, it is the maximum temperature that we have in a given city, and all the measurements are taken. And just to make sense of the graph, let's look at some of the values and try and write down what is happening. So in January, you have that the temperature in degrees is 4. In February, the maximum is 5. In March, the maximum is 8. April, the maximum is 13. July, in August, it's actually got a maximum temperature of 26. So if July, August have got maximum temperatures, then we're obviously talking about what kind of countries would exhibit those kind of temperatures. Any country above the equator could be one of these countries. And so I think we've understood what the graph is showing us the maximum temperature of 26 happens in August, and then it comes down to December, and with a minimum temperature in January and February. So we've made sense of what is happening. Temperatures are going from 4 degrees to 26 degrees, and let's see what the first question is. What is the range of the monthly maximum temperatures? And the range means there's a minimum value and there's a maximum value. And how does it range? So again, if we look at the minimum, we saw that the minimum was 4. And we saw that the maximum was 26 degrees. So therefore, the range is 22 degrees. So this city varies in temperature by 22 degrees within the 12 months of the year. Right, then they would like to know what is the mean monthly maximum temperature. So what would the mean, or what would the average of all the 12 temperatures be? And I think we're going to write them on the side here, because we'll need to insert these onto a calculator. So we can see that in January we have a 4, then we have a 5, then we have a 8, then we have a 13, there's a 19, there's a 22, there's a 25, there's a 26, comes down to 23, it then comes down to 17, 14, and the last one is 7. Let's just check that. 7 is over here. Okay, so let's use our calculator. And grade 11s, you tell me, how do I switch on my calculator to work out the average? Where must I be? Well, my calculator cannot have any stat. If there is a stat in there, actually, let's just set up 2. Okay. If you have a stat in your calculator and you're starting off a new question, you need to clear the memory of the last set of data that was on your calculator. So you first need to just get rid of the stat, okay? And let's just get rid of that. Okay, I got rid of my stat by just using the mode 1. And now I start again, so I can now set up mode 2. Now in mode 2, you've got 1, 2, 3, 4, 5, 6. That's as many menus as possible. All these are looking at various functions. The mode that you want is 1. 1 for variance. We're looking at the variance. And the moment you set it up in 1, you'll have X. Frequency, you set it up on mode. And you can leave the frequency there or you can leave it out. It doesn't really matter. If we're wanting to work with a class of data, we would need to know the frequency. So I'm just going to enter these values. 4 equals 5 equals 8 equals 13, enter 19, enter 22. We've got a 25, a 26. We have a 23, also a 17, and then we have a 14 and a 7. Now, how many data points should we have entered? We've entered 12, so the cursor's gone on to number 13. Okay, we've entered the data. We can now press all clear. You have not lost any data. I want to show you how you can retrieve it. If you press the stat button here, this number 1, you now have a menu that shows you what type of data, the data that you have. This gives you the sum of the data, gives you the variance, and it gives you the minimum and the maximum as well. So if we enter 5, for example, and we want to know what the minimum of that data is, we just press 1, and it tells us the minimum was 4. We've already established that the minimum was 4. So it can calculate minimum for you. And you can press the all clear all the time. And as I said to you, the data will be stored there. If I show you the data, number 2, can you see 4, 5, 8? It's still stored in there perfectly. So as long as you don't set up or change your mode to 1, your data will be there all the time. So you can actually all clear. Now, we wanted the mean. And the mean we often say is X bar. So that's what we're looking for. Back to the stat button over here. That's where we will find all the statistics features. We don't want the data. We can add up the data if we want. It's got the sum of x squared and it's got the sum of x. And grade 11, just in terms of terminology, this sign is the Greek letter sigma. And it stands for, since it's S, it stands for the English word sum. So if you want to add up all your data points, it will be under that. So back to here, that would be your sum squared, and that's just the sum of all your x's, sigma x. So if we wanted to know the sum of all the points, that would just be 183. And because that adds up to 183, we could then say, since they're 12 months, we can divide that by 12, and that gives us the mean. So it's 15,25 degrees Celsius. Now, that is if we had to do it manually. But the calculator has actually got a button that can calculate that mean. So if I clear it out, go back into the stats menu, it's under number 4. Number 4 gives you how many did you enter. So if we press 1, we entered 12. It then gives you what is the average to, we've worked it out 15,25. Watch how smart the calculator is. Watch how it tells you 15,25. That's fantastic. And then it also gives you, unfortunately, you've got to keep going back into it. It gives you the standard deviation, which is 7,59, so 7,6 degrees. So the standard deviation is 7,6 degrees Celsius. Now, what does that 7,6 degrees Celsius tell us is that there are a certain number of data or a certain number of temperatures that are around that mean of 15 degrees, but those temperatures vary by 14 degrees. It's 7 degrees on either side of the mean. Now, if we wanted to find out how many of the months were actually sitting between there, we could actually calculate that. So this was actually 7, no, this was 15. Your mean was 15,25. Okay. Now, that's the mean of 15,25. And let's just write this nicely. Okay, so it's 15,25. Then 7 degrees to the left of this and 7 degrees to the right. We say that we have certain temperatures that are within this range. So this would represent a, just see what this is, 7,6. So make it 7.6. If we times by 2, we get a difference of 15 degrees. So this is a variance of 15,2 degrees. And if we subtract 15,25 from 15,2, look what happens. 15.25 minus 7.6, we get 7.65. So we get 7,65 degrees. And on the other side, we have 15.25 plus our 7.65. We get 22,9. So let's see how many months fall within the maximum temperatures. How many months fall within the 7,65 to 22,9 between these 15 degrees Celsius? So we go back to our graph, and 7 would be 7,65. So it would really be from there to 22,9, which was just before this 23 value. So we would get this one, 2, 3, 4, 5, 6, and then that one's below. So we've got 1, 2, 3, 4, 5, 6. 6 months are sitting out of the 12, are sitting between 7,5. So 6 months are around the mean. Now 6 months out of the 12 is suggesting that 50% of the data is sitting between the first standard deviation. So we call this the first deviation, the negative one, and we call this one the first positive deviation. And you'll find that there's always a percentage that's sitting between those first two deviations. There's a theoretical value that if you have 67% of the data sitting between that, then it's normally distributed. Otherwise, we say that this curve is not normally distributed. And that is an aspect of statistics that we haven't discussed before, but I thought I would just share that with you. I think we need a break, Queen.
Yes, I think it's about that time for an ad break. But before we do that, I've got some really, really great news that you guys are going to love. Now, mindsetters, do you want to be a proud owner of a Chevy L-Spark car? Yes, I'm talking about a car. Now, it's very easy and simple. If you want to win yourself that car, all you have to do is buy yourself a Safeways K53 book, or you can also purchase the app on Google Play Store or the Samsung Galaxy App Store. And remember to keep your receipt, guys. It is very important that you keep your receipts if you want to enter the competition. And after that, all you're going to have to do is simply go onto our Facebook page or the Safeways K53 page, like both pages, and click on the competition tab on the Mindset Learn page. Then all you have to do is then enter your details, all the details, guys. Remember to fill in every single thing that we need from you guys. And then there you go. You've entered yourself and you are now in the running of winning yourself a very cool car. Now, it is very easy and simple as that. So, guys, please remember that you can win yourself a car just by purchasing this book and getting your learner's license. Now, with all that being said, let's quickly take an ad break and we'll see you guys after this. All right, welcome back, grade 11s. We are still tuned into the mathematics show with myself, Queen, and Dina. And if you guys have just tuned in with us, don't worry, we haven't gone that far into the show, so I'm sure you can still catch on with us. And can I quickly please announce the winner of last week's Test Yourself competition? This winner gets themselves a very cool, awesome Casio calculator. And our winner is Mpho Tlaka. Congratulations, Mpho. All you have to do is stay tuned and find out how you can get yourself that Casio calculator, because it's coming your way. Very, very well done to you guys. Remember, all you have to do to win yourself that calculator is go into the Test Yourself competition and answer the question correctly, and you could possibly be the winner of the calculator. Let's continue with today's lesson. Dina?
Welcome back, grade 11s. I left you by talking about the standard deviation and how the data was spread around the mean. And we found that 6 months was spread around the mean, and they were 15,2 degrees apart. So I would say they were quite widely scattered. Now, I just wanted to show you something else. If I keep minusing, so if I keep going to my second deviation, then I will subtract another 7,6 degrees. So minus 7,6 degrees. I will get a 0,6 on this side. And if I take my 22,9 and I add on 7.65, I will get 30,55. So I will get 30,55. And this would be my second deviation. So we talk about the first deviation, the second deviation, and we would now have how many temperatures would be between 0,6 and 30. Now that would be all of them. So we actually have found that all 12 months are sitting in between these temperatures. So we would get all 12 data points within that second deviation. So you see that it hasn't gone as far as a third deviation. So we could actually plot those points to form a smooth curve. And usually when the curve is, actually we've actually got those points there. There's my curve. When the curve has got its mean in the middle over here, we would then say it's normally distributed. In this way, it's not a normally distributed curve, as we don't have 67% of the data within the first deviation. So there is a measure to which we are comparing whether our deviation, whether our data is normally distributed or not. Okay, so there was a follow-up question to this one, and that was, we've calculated the standard deviation. The calculator actually does that for us, and the deviation was 7,6 degrees Celsius. So the temperatures varied by 7.6 to the right of the mean and 7.6 to the left of the mean. So there was a 15,2 degree variation around how those months were clustered around the mean. And with that variation of 7 degrees, I'm afraid it would be difficult to predict on any particular month what the what months would actually, or what value the temperatures would be, because there is such a big variation. Okay, then there is something around a prediction. So a prediction that 100 years from now, global warming is likely to increase the city's monthly maximum temperature by 5 degrees in December, January, and February. So the coldest months are going to increase by 5 degrees, and the other months are going to increase by 1 degree. By how much do you think the mean is going to increase? What would you do to calculate the mean, or the new mean, if the smallest months increased by 5 and every other month just increased by 1? How would the mean increase? Well, we could take, instead of going to recalculate all those temperatures, we can just calculate the mean of the increase, because that would really tell us what that mean would be. So we have 1, 2, 3 months at 5 degrees. 3 months at 5 degrees would be an increase by 15 degrees. And we've got 9 months at 1 degree Celsius. So that would be the total increase in the maximum temperature that I would get. And I have 12 of those months, so that would give me an average of 9 plus 15, would be 24 divided by 2. So the mean, it would actually be 2 degrees Celsius. So whereas the mean now is 15 degrees Celsius, the prediction that they're giving us it would be that the new mean would be 17 degrees Celsius. So that's the effects of global warming. Now, what do you think is the effect that the predicted increases in temperature will have on the standard deviation? Okay, so the standard deviation works with the range. The wider your range, or the greater the range, the bigger that standard deviation is, the further away the values are scattered around the mean. So think about what is happening to your increases. The months 4, 5, 6, those temperatures are going to go up by 5 degrees. The other months are going up by 1. So what impact do you think that kind of an increase will have? Well, think about it. Your minimum was 4, your minimum is now 9. But your maximum is not increasing by a lot more. It's only increasing by 1 degree, and our maximum was 26 degrees. So our range has now become 27 all the way through to 9, which is now 18 degrees. So the range that we calculated earlier was 22 degrees. Now it's 18. The closer your range is, the more clustered your points are around the mean. So therefore, the smaller your deviation. So the closer your range, the closer your points are to the mean, the smaller your deviation is. Okay, so really to understand what is happening to the range will impact what's happening to the deviation as well. So you could go now and enter onto your calculator all those new temperatures with 3 degrees added onto it, and you could recalculate the standard deviation, but they don't actually ask you. They say describe the effect. So we needed to look at the effect that the increase would have on the standard deviation, and we just had to justify our answer. So something as simple as the range will become 27 degrees through to 9 degrees Celsius, therefore 18 degrees. So a smaller range will imply a smaller deviation. So the deviation, therefore, decreases. And you can go and calculate those values on your calculator and see that the deviation, which is now 7.6, will probably become around 6 degrees or so. All right, so let's leave the temperatures alone for a little while. Let's go on to, let's see what this is about. Right, duration of calls. Let's go on to some telephone calls. The length of time in minutes, this is extremely important. You need to know what is the meaning of the data. So the length in time in minutes of a certain number of telephone calls was recorded. No calls lasted 25 minutes or longer. A cumulative frequency diagram of this data is shown below. Okay, so let's talk about what the data is telling us. Person A made a phone call. They measured the length of the phone call. They recorded the length of the phone call in minutes. They took person B, measured the length of the phone call, recorded the length of the phone call. So they did all that. How many people did they do it for? We need to go and look. But what's important that they tell us is that no call lasted 25 minutes or longer. So the telephone calls had to be from 0 all the way through 25 minutes, excluding that 25 minutes. It could have been 24.5 minutes long. So I think we understand what's happening. Phone calls were measured, the length of the phone calls were measured, data was recorded, and now we need to make sense of the cumulative frequency diagram that is given. Okay, what do we call this curve when the cumulative frequency curve is drawn? It's called an ogive, and it's giving us some very important information. The first little bit of information is how many people whose phone calls were recorded. How many people were in the research? The last value will tell us, so 40 people's phone calls were recorded. Okay, so I had 40 people whose telephone calls were measured, whose length were measured, and they were recorded. So the cumulative frequency always tells us the total number of data points. And then it tells us that between 20 and 25 minutes, we have that many people. Between 15 and 20 minutes, we have that many people. Between 10 and 15, we have that many people. Between 10 and 5, we've got that many people. So it's not giving us the exact number of people. The only exact number we have in OGIVE is the total number. But in the classes, it's impossible to determine how many did for 21, 22, 23, because that would be too difficult to record. So we make it easy and we say, just give me how many people had phone calls between 20 and 25 minutes. I think that's a gauge that you're making. So we now take the classes and see what the questions are about. But before we go there, I want to ask you, how would you find the median length of the phone call? What would we do to go and find what would be the middle, that middle length of phone call? So yes, 40 people were measured in the total. Yes, the phone calls were between 0 and 25. But if you looked at between 0 and 25, what value would be the middle value for us in this data by using the median? The median always divides things in half, so the median would be found at 20. This would be the median value. So that's how easy it is to find the median, because it's always the value that's half of the total value. So I go to where half is, and that's my median value. So I go to my median, and I now read off my cumulative frequency what is the middle value of my phone calls. And my middle value is 16, 17, 18, 19. So it's just 15 and a half, possibly 15 minutes. So my middle value, I'm saying that the majority of the people were actually looking at a phone call of about 15 minutes in length. That's what the middle value is telling us. Another value that's very important for you to work on, the cumulative frequency, is Q1. Where would the first quartile be? And the first quartile would be at 10, because again, I take half of that data. So Q1 would be at 11 minutes. That would be 11. And Q3 would be half of that as well, so it would be at 30. That would be Q3. And how many would be at Q3? That would be 19 minutes. Okay, so now I'm beginning to make sense of the data. I'm saying that half of the people that were observed phoned for between 11 and 19 minutes. Not 15 minutes, but between 11 and 19. Because if you have to do a box plot out of that, very often they'll ask you, take your cumulative frequency and draw a box plot of the data. Let's draw that box plot. What does it look like? It has a median at 15 and a half. It then has, so if we look at 14, 13, 12, 11, it has a Q1 at 11, and it has, there were some calls here between 0 and 5, so that's 11. And then go all the way here, so if that's 10, there's 12, 13, 14, 15 and a half, so that's my median. So here's my box plot, and my whisker goes all the way down to my 0 phone calls. And then Q3 is at 19, so it's 16, 17, 18, 19. So there's where it ends, and then I've got my whisker to the end. So here's my end of the box plot at 19, and then I go all the way to, it was 25 minutes, just before 25, 20, 23, 24, 25. So it goes all the way to the maximum. Okay, so what we're saying with the interquartile range, which is going to be this value here, the interquartile range is 19 minus 11. There's a range of 8 minutes. between 11 minutes and 19 minutes. So we are saying that for 20 of the calls were made between 11 and 19 minutes. We're also saying that a quarter of the calls were made less than 11 minutes, only a quarter of the calls, and we're saying that the other quarter were above 19 minutes. So what is a quarter of 40? We're saying 10. So we're saying that 10, so here are 10 callers, 10 calls were made less than 11 minutes. We're saying that 10 calls were made between 19 and 24 minutes. But we are saying that 20 callers made calls between 11 and 19 minutes. And that is how the box plot really defines for us how we can describe how that data has been represented. So we work with halves and quarters. A quarter of the data is the whisker to the minimum. A quarter of the data is Q3 to the maximum. And then 50% is sitting around the median. Here's the median. And we are saying that that interquartile range varies only by 8 minutes. So within 8 minutes, around that 15 minute, we can tell that those 20 callers are making those calls. And then we get another 20, 10 on either side that are making calls that are less than or more than 11 and 19. Okay, so that is a very effective way of finding the median when you have classes of numbers, because that's what the cumulative frequency is doing. So if we now take, let's just see if the next question's up there. Yes. If we now take the frequency table, if we go and find a frequency table, okay, I don't really have space to draw the frequency table, so I think we'll draw it up here. Is that this value here indicates the last in the class. So if we go from 0 to 5, and let's take t in minutes. So t goes, and let's include the 5 here and the 0 there. Then we are talking about how many calls here? This is 1, 2, 3, 4. So there were 3 callers. Let's say that there were 3 calls here in this section. Then in this section over here, up to there, we would say t is more than 10, but I've already included the 5 there, so I'm going to say it's bigger than 5. And there were, let's just read it off here. There were actually 5, 6, 7, 8. There were 8 callers, but now that's the cumulative frequency. So just in class, in this blue class there, from that point to that point, there were actually 8 minus 3, there were actually 5. Okay, and then we keep doing that, and we go through to this section over here, which would be a time between 15 and 10. And there was a total here of 18. That's the total. Okay? So that's the cumulative frequency up to that stage. But there were 8 up to that stage. So just in that class, in this class, there were 10. And we keep doing that. So we look at this class of values, t between 20 and 15. We would have a total of 33. But in this class only, we would have 33 minus 18, which would be 15. Just in that class. And the last class would be this class here, which would be between 25. In fact, it didn't include 25 because they said no, there was no phone call equal to 25. So t was less than 25 and greater than 20. There's a cumulative total of 40, but there were 33 here. So there were actually only 7 in this class. And so we can set up a frequency table, and from the frequency table, we could actually draw the histogram. But I think we need to take a break.
All right, guys, so it's time for that quick ad break. You guys can go refresh yourselves a little bit, then we'll see you after this. Welcome back, grade 11s. I hope you guys enjoyed that mini ad break and you made the most of it. We are now in the last segment of today's show. And remember, guys, we have that awesome competition for the Cave 53 app or book or downloading the app competition. All you have to do is just purchase this book, download the app, and then you can follow the competition details on our Facebook page. Now, I'm still in the process of actually getting my learner's license, and I'm finding it very, very useful. Dina, when did you get your learner's license?
Way back in the last millennium.
And what resources did you use to actually pass the test?
Oh, just found a book, learned the signs, learned the rules, and wrote the exam. Pretty easy.
Wow, guys.
But you need a book.
Yes, of course, you definitely need the book. It's very easy and simple. So please do join us in this competition, and then you could get yourself a car. So, Dina, let's get straight into the show. I have a few questions from Mindsetters, and one is from Sahil, and he would like to know, how do we know if data is positively skewed or negatively skewed?
Okay, that's a very, very good question. It's apt for the section. How can you describe the data, not only in terms of its dispersion, but also if there's some tendency to lean towards one side as opposed to the other side. And I will certainly look at the challenge question and bring that in there, because there's a comparison there that's very worthwhile to look at. So we're going to hold on to that before we carry on. Any other questions?
Right, we've also got a question from Musawe Nkosi, and he wants to know, how can he calculate variance using a calculator?
Okay, the variance is a word that is used to describe the square of the standard deviation. There's a whole formula that uses how to find the standard deviation manually. So you would work out the differences between the data point and the mean. You would then square those, and you would get a sum total, and you would then divide by the total number of data points. And that value that you get, the sum of the squares, divided by the total number of data points, would be then the variance. And you would then take the square root of that to unsquare it, and that would be your standard deviation. So the variance, you just square your standard deviation. So in our question today, we had a standard deviation of 7,6. If you square 7,6, you get your variance. And the square root of your variance gives you a 7,6.
All right, and we have a quick last question from Daniel, and he wants to know, in a histogram, is it compulsory for the width of each bar to be the same?
Is it compulsory? I would say it's more, I would tend towards it being more convenient to be the same, so that your graph is a little bit more, the visual aspect of it brings out some mathematical coherence or visual coherency. Yes, maybe compulsory, but we don't do that many histograms, but oftentimes we do keep them same length.
All right.
Okay, good. All right, grade 11. So I left you with the reading of the various classes of points. And we read off the cumulative frequency. So I want to show you how you can extract the frequency of those classes. So the graph gave us a class, and it gave us the total. It gave us another class, and it gave us a total. Gave us another class, gave us a total. Class total, class total. We want to now work out how many were in each of these classes. So that's obvious. That must be 3. So how many were in the 5 to 10 minutes? If the total of these two was 8, then that must mean that we take 8 minus 3 is 5. 18 minus 8 is 10. 33 minus 18 is 15, and 40 minus 33 is 7. So in each class we can say how many calls there were, which shows us really that at 15 minutes that's where the median was, because it's almost like the mode is also hanging around or hovering around those 15 callers here as well. So we do tend to see that the median would be coming from this value, and it did. If you remember, it was a 15,2, I think it was, or 15,6. minutes. So there's your frequency. Once you have the frequency, you can actually then plot the histogram, because this was to draw a histogram. So the histogram, I must actually know what my class is. And I could now say that if this was my class from 0 to 5 minutes, there were 3 people. So I could just go up there and color in my 3. So that would show my 3. Then I could go between 5 and 10, and there were 5 people. So I could go up 3, 4, 5, and there were 5 people. And this answers the mindsetter's question, should they be the same length apart? And in this case, your class is actually being represented by 5 minutes. So yes, they should be equal lengths apart. Okay, so let's look at the challenge question so that we can discuss the mindsetter's question on what is what is positively skewed and what is negatively skewed. Okay. Now, if you look at this bar graph, this was class B, what information are you getting out of this graph? And I wish now that you could talk to me, because I'd love to hear your language, the way that you're speaking about this graph. Because the one word that you cannot use in this box and whisker plot is that the majority of the learners got below 60%. Okay, so if you're using the word majority in a box and whisker plot, you're in the wrong class, you're in the wrong forum, you're just nowhere understanding what this box and whisker is doing. Okay, they told you that there were 25 learners. So what this is telling us is that 12 learners are getting between 30 and 70%. It's telling me that 12, and I'm not going to say 12 and a half learners, because you can't get half a learner. So I'm saying 12 learners got that between 30 and 70. I'm also saying that 6 learners got between 10 and 30, and I'm saying that 6 learners got between 10 and 90. Then, out of those 12 learners here, there are 6 learners that got between 30 and 60, and there are 6 learners that got between 60 and 70. Why can I say that? I am exact. When it comes to an IQR, when it comes to a box and whisker plot, it is a measure of exactness, if I can call it that, because the data is bisected. So this line bisects that section. This line bisects that section. This line bisects that section. And so we're talking about half of those data points. So half of the learners, half of the learners, half of the learners, not the majority. Now, why do we say majority? We say majority because this box, you can see it's quite wide from that median, as opposed to this little box that's quite narrow. And so that visual representation, we tend to say the majority. But that stretch does not imply the majority. That stretch implies that 6 learners' marks vary between 30 and 60. Whereas in this section over here, 6 learners got between 60 and 70. So there's a 10% difference in these 6 learners. They're quite clustered around that median. Whereas here, there's a 30% difference amongst those 6 learners. Okay, so we cannot say the word majority. We have to speak about the data being bisected. And, something happened. All right, let's just clear this quickly. And, okay, so the question was, is it positively or negatively skewed? Now that we understand that these learners here are having a difference of 30%, we speak about that the data is negatively skewed. The only reason we're saying it's negatively skewed is because the spread is towards the left. Where is the spread of the data? It's to the left-hand side. So whenever that data spreads out, so there's a tail on the one side, we speak about it's negatively skewed or positively or skewed in that direction. So that's negatively skewed. If this had to be the other way around, if your tail was that way, then it's skewed to the right, and if the spread is to the right, then it's skewed positively skewed. So it's a terminology that we use in mathematics to describe the spread.
All right, there we go, guys. Where we have it, our challenge question. And we've got a few mindsetters who actually have the answers to the challenge question. So if you're still trying to figure it out, then you can still compare with the mindsetters who've posted their answers. We've reached the end of the show, unfortunately. So it is actually goodbye from me and from Dina. Bye, mindsetters.
Bye. All the best for your exams.